Hello, everyone. So my conference t-shirt did not arrive yet, so I have to wear my own t-shirt. Welcome to my presentation. We have nearly 1 million lines of Python code in production, and now. In summer 2016, we started to think about this question. I'm going to present how we solved this problem and what you can learn for your own big and small Python 2 migration projects. Let me start by introducing myself. My name is Michael Howitz. I'm from Germany, so it's quite difficult for an American to spell my name correctly, to pronounce it correctly, but that's no problem. Since 2003, I am a Python software developer. I was the head of development in the migration project. My presentation is based on. My employer is a small software and consulting company named Gocept. It is located in Halle, Saale, Germany. We do not have own products we sell, but we develop and maintain projects for customers. Currently, we work on some projects, migrating them to Python 3, or even already having finished the migration. I'd like to say thank you to Gocept for the time to prepare and to give this talk. Now you know a little bit about me. Let me ask a single question to you. There is already a poll. On the right side in your browser. I took this question from the Python 2 end of life survey. It was done by Active State in the last quarter of 2019. So the question might sound a bit off now as time has moved on. But nevertheless, the question is, how prepared do you feel for the Python 2 end of life? There are 3 possible answers: not prepared, somewhat prepared, and highly prepared. So if you can use the poll to answer now. To see the answers, I have to answer it myself. Okay, there are some answers. I'm going to show you the answers of the survey. About half of the participants felt highly prepared. This is not monitored by our poll, but a third did not feel prepared at all. The end of life of Python 2 is now already history. If you still do not feel well enough prepared to handle that event, let's see what this presentation can give you. I scheduled the following 4 items for you: discussion of the approaches, introduction into union.cms as I use it as an example project, doing the migration, and at last but not least, tips and tricks. Let's dive into a discussion about possible approaches, what to do with an application running on Python 2. Discussion means here that I am the only one who discusses. Sorry, I'm going to present the following 5 approaches: sunset the application, replace by something off the shelf, don't migrate, start over or fade out, move to Python 3. Python 2 is after end of its life, maybe your application too. So ask yourself, how important is the business case this application supports? How long will I or my company earn money using this business case? Can a migration be a success, even financially? This approach might be the cheapest and most safe one if it is possible at all. But you should at least think about it. Don't burn money by touching an application which is not or no longer worth investing into it. Is your application so special that it cannot be replaced? Maybe you can even replace it by something off the shelf. It is probably cheaper to buy a service from a company than doing everything yourself. Yes, I know there was a time when it was cool to write your own tools. Nowadays, there are lots of specialized service providers who can do a much better job. If you want to keep your tool, it's your baby. You have to take care of it. On the other hand, you mostly only get an 80% solution. Maybe you can work around the missing 20%. One of our customers is replacing big parts of their homegrown enterprise ERP system by products backed by companies. The bug tracker, the internal CMS, the calendar. And if you are following this approach, you have only to migrate the data. I know this can cause big trouble, but you have to do it only once. After the migration, the problem is the problem of the service provider. They have to keep the service running and to fulfill feature requests. The maintenance burden is then on their side. You and your users might need to learn a new tool. The users might require some customizations. Being forced to tell the user the new application cannot do this, let's find a way around, might cause much less stress than having to ask, when do you need this new feature? Even my company, as a software shop, has a slogan which roughly translates into English, better buy instead of develop it on your own. The next approach might be dangerous. Don't migrate. My boss won't like that I mention this approach here because it could ruin our business or save it if you are forced to change your mind in 2 years. If the use case of your application will go away soon, neither maintenance nor development or new features are required, then there are no bugs to fix, this approach might be a fit for you. But be careful. Don't use this approach on critical infrastructure, which ran for years and nobody wants to take care of. What will happen if the server running the application dies? Okay, might be no problem. It runs in a virtual machine or a Docker container, or doesn't it? But will you be able to find help if you have problems with the code in the next 2 years? So be aware, it will become harder to keep an old application running and find someone to invest time into it. If it is all ruins, maybe start over. Directly in Python 3 or even in another language. Try to keep at least the high-level tests. There are many people who say, don't do this. And I am one of them. It might be interesting to start on a new ground. In the beginning, it looks like a great opportunity to do everything correct now, like you read it in the book. Often this will become a great nightmare, at least for big enough projects. You can do this for a microservice, but not for a monolith application. There might be exceptions to the rule of thumb, but why do you think you are one of the exceptions? Rewrite projects are the ones which rarely succeed. Only rewriting is never enough. The new application should also be a lot more flexible and have a ton of new features. Too much planned for too little time, as always. And you still have to migrate the data. Or do you dare to use the same old database for the new application? During the rewrite, the old code still has to be maintained. Change requests now have to be implemented in both variants, the old and the new one. You have to learn the use cases again, which led to the former application, or do you have up-to-date requirement documentation? Users will not be happy with the new application because it behaves differently. The old one they used to complain about will over time becomes a secret weapon to get things done. The minimal viable product will be quite big, especially if there's a working version the users know and trust. There's a sub-approach to start over named fade out. Replace the parts of the old monolith one by one with new parts. This might work, but wouldn't it be easier if the monolith already runs on a current Python version? So you don't have to think in different Python versions if you work on the monolith and its successors. If nothing helps, you could even try to move your code and tests over to Python 3. For me, this is the most interesting approach because I love legacy code. I admire the people who created it, and if I can make it even better, it would be a great opportunity. Of all the approaches, this is the most future-proof one. It uses what's already running in production and only transforms it. This can be challenging, but until now, it was possible for each and every project we touch as company. Let me introduce union.cms. Union.cms is a content management system once written for Verdi, a German trade union. Its first version went into production as early as 2003. It is also now used by DGB, also known as Deutscher Gewerkschaftsbund. Union.cms is a multi-site, multi-user content management system. It has thousands of content editors and serves its content to some million visitors. Sorry, the source code is not publicly available. When we as a company first touched union.cms in 2009, it was based on ZOP2 and the ZOP object database, ZODB. It was probably running on Python 2.6, as Python 2.7 was not yet finally released those days. Over the years, we developed many new features for the CMS. So finally, we ended up having nearly 1 million lines of Python code together in the core of the CMS and in the projects using the CMS built on top of the core. The customers are interested to keep this CMS running and maintainable for the next coming years. So there was no way to sunset the application. Do not migrate was also a no-go because of security considerations. Replacing union.cms or starting over was also no opportunity. The customers invested much time and effort in the previous years to train the editors, to create or migrate content from an older union.cms version. So we were happy to migrate the core and the projects built upon to Python 3. Now let's take a look at the migration steps which worked well for union.cms. I believe they can be used in Python 3 migration projects of all sizes. I'm going to present 5 main steps. Step 1 is general preparation. This means have someone who knows Python 2 and Python 3 and the differences in between. There are enough tutorials on the web, so I'm not going to cover this here. It deeply helps to have a decent test coverage. This means you have to report the tests too, but Test coverage gives you confidence that the code still runs. In union.cms, we currently have about 88% test coverage of the Python code. That sounds not too much, but I think it's not so bad. When we started, union.cms had less test coverage. It increased over the time during the migration project. Sorry, but I do not have the actual numbers from where we started. Currently, the 88% are quite good enough. Annotating each function with the expected types for the input and output, also known as type annotation, might help. Checkers like MyPy are able to find problems by statically analyzing your code. But in Python 2, type annotations have to be comments instead of being part of the language. So we decided against using type annotations for the migration. It seemed too much hassle for an unknown gain, even if you have to port the type annotation, also to port them from the comments to the language. Step 2 of the migration is clean up code and test. This means all tests should be running and passing. Broken or disabled tests are generally no good idea. You should try to fix them or delete them if nothing helps. Some parts of the code are probably unused. You should not port them. The ones used will be difficult enough to port. So there's no need to work on dead code. In union.cms, this required a lot of detective work. Find code which is no longer used, where there were Python modules which were not even imported, so they had no PyC files. There were classes and functions which were not used anywhere, even not tested, so they did not have test coverage. We had the advantage to know the code base relatively well to find that dead code, or at least hopefully most of it. The rest got ported, even if this was not needed. Removing dead code should be done like a surgeon, symbol by symbol, functioner by functioner, class by class. Remove everything the dead code needs. That includes imports, global variables, registrations, etc. Each deleted line which is not needed to be ported, you do not need to support it later on too. Step 3 of the migration is bring dependencies to Python 3. This means you need a list of all direct and transitive Python package dependencies of your application. Transitive dependencies are the dependencies of the dependencies, and the dependencies of the dependencies of the dependencies, you know. How to get this list depends on the tools you use. Only 2 examples. If you're using pip to install your dependencies, call pip freeze to get this list. union.cms uses a ZC buildout. It lists the needed dependencies in the generated run scripts. Each dependency has to be checked for Python 3 compatibility individually. This means look up the package at the Python package index, aka PyPI, to see if there's a version which declares Python 3 support. I know this could be automated. You could leave out the step, but looking at the package gives you a feeling for the package. When was its last release? Does the package still seem to be actively developed? Which version was the last one which supports both Python 2 and Python 3? On the next slide, I'm going to suggest to port to Python 3, but keeping Python 2 compatibility at least for a while. So this information about Python 2 is needed. This step could also be used to introspect the stack you're building upon. Possibly you will find packages which should be replaced or even have maintained successor packages. At the end of this step, you have a snapshot of the versions you're using, the package versions needed for Python 3 compatibility, the maximum package version numbers to keep Python 2 compatibility. When you know the needed versions, you can use them. Make sure you run on the newest versions which are Python 2 compatible. This might require some changes in your code, so it works with these newer versions. This, of course, also means run on the latest version of Python 2.7. There might be dependencies which are not yet ported to Python 3. You could try to replace them with other packages. According to this already cited active state survey, finding replacement packages, more than half of the participants of the survey expected this to be a challenge in the migration. Sometimes you are the chosen one to port a package to Python 3. You could see this as an exercise for the migration of your application. Maybe it is enough to port the parts of the package you actually use. To get a clear plan where to start porting your application, you might need a dependency tree of the packages belonging to your application. It should at least exist in your head. The packages without dependencies, the packages with circular dependencies, which need to be ported together to be at least the interdependent parts, and the packages which need the whole core to be ported before. In union.cms, even it's quite large, we knew the dependencies well enough, so there was no need for an explicit dependency tree written on paper. Unfortunately, I cannot suggest a good tool for creating that dependency tree. The only one I used more than once is called TLActubs, but it might not fit your use case. Step 4 of the migration, migrate the code. There are several tools to help you. Modernize is a package created by Armin Ronacher, the developer of Flask and many other Python packages. It is used to convert Python 2 code so it can run both on Python 2 and Python 3. To achieve this, it adds a dependency to a library named 6, as 2 times 3 is 6. Depending on this 6 library makes it pretty easy to drop Python 2 support code later on, as the code needed for compatibility is marked by using this library. Although this step automatically changes the code, we had very little problems with the changes it created. We were happy about this first step running automatically, as it was clear the next steps would require manual work. There is an alternative to modernize called futurize. It adds a dependency to a library named future. I personally do not like this library. It seems not as lightweight as 6, which provides only one module for the whole code. Future provides many modules. When looking at the modules provided by this library, it's not always possible to tell whether they belong to the standard library or to the future library. It feels future is not made as a temporary dependency, which you will easily be able to remove after the migration. There are problems which cannot be automatically fixed, but they can be detected. For instance, in a Python 3 class, if your Python 3 class provides a method dunder equal for equality comparison, it also has to implement dunder hash. Pylint, the tool I suggest here, has a mode to find such issues. You need to install a Pylint version older than version 2 on Python 2. Newer Pylint versions are Python 3 only and no longer contain the needed checkers. Pylint will tell you about some problems not even your tests will find, but they can cause trouble when running the application. And now the heavy lifting follows. Run the tests and fix them until they pass. There might even be import errors which already disturb the test collection. Many of them will be due to relative imports which are no longer supported in Python 3. Running the tests will show all the problems Modernize and Pilot could not find, for instance, string IO versus bytes IO. Ask a web search engine of your choice for specific problems. There are already solutions for most of these problems. I added 2 example pages in the links section on the last page of the presentation, which I will show you at the end. If you are using PyTests to run your tests, the plugin PyTest Quarantine can come handy. It allows to curate a list of failing tests. This way, you always know which tests you still have to fix. And you see if you broke tests by your changes, which were successful before. You are even able to commit the quarantine list to your repository so multiple developers can work on fixing the tests. Make sure the tests still pass in Python 2, so you're always able to deploy this code to production, even if you are working on the migration to Python 3. In union.cms, it was really helpful to add comments to the code branches only needed for a specific Python version using #py2, respectively #py3. This made it easier later on to remove Python 2 compatibility code by grabbing for these markers. And now, step 5 of the migration, switch to Python 3. This means run your application instance against an at least fairly empty database. This way you make sure the instance starts at least. You might find some Unicode versus bytes issues while clicking through the application. Maybe you should write some additional tests for the problems you find. When the application runs, it might be time to migrate the data. At least in union.cms, we had to do this because union.cms uses ZODB, which stores Python pickle objects. Python pickle objects behave differently on Python 2 and Python 3. If you store an object with an instance of a string of str in Python 2, it can have an arbitrary encoding as it is actually bytes data. But Python 3, when loading this pickle, expects the str instance to be UTF-8 encoded, as it expects it to contain text data. If you're using a relational database, you're probably lucky and you are probably able to skip this step. Now you can deploy the application to a staging environment to test it in depth from end to end. Even with 100% test coverage, some issues might slip through. union.cms was tested by the editors who use it in their day job. They even wrote a test manual for an external tester to test it on the different installations. Be aware that the testers will find bugs the automatic test did not find. Additionally, they will find bugs which already existed before the Python 3 migration was started. So you have to decide what to do with these bugs. After a successful test on staging, it's time for the rollout to production. Maybe you can do a canary rollout. This means that only a small fraction of your users hit the server running on Python 3, fix the errors which occur, and then increase the portion of users which see the Python 3 version over time up to 100%. In union.cms, this approach was not possible as the database had to be converted to be usable on Python 3. And after the conversion, it was no longer usable on Python 2. So we stopped editing for a weekend, converted a copy of the database, and went back online after the conversion. The rollout went smooth thanks to the many testers of the staging environment. There is one final step: drop the Python 2 support. An application can only run on a single Python version. So after a successful deployment on Python 3, the Python 2 compatibility code is no longer needed. The code branches checking for the Python versions cause at least some performance. Comments in the code about specific Python versions might distract the developers. It seems to be the best approach to drop support for Python 2 in a coordinated way. So altogether for the whole application, instead of when the code is touched next time. This can be in some years. There's a tool called PyUpgrade, which can be used to remove most parts where the library 6 is used. So it automatically changes the code to remove this dependency and the code branches you create using 6. Additionally, it is able to convert the code to be modern Python 3, including the usage of f-strings. After running this tool, you can remove the imports of 6 and clean up the places you marked with Py2 or Py3 if you did it as I suggested before. Don't underestimate this step. Even reading through the diff when removing Python 2 compatibility is a lengthy task, and there are lines which could be even be improved. Don't forget to update the dependencies to the newest Python 3 versions too. Some words about the time schedule. We used the following metrics to compute the effort for porting union.cms to Python 3. At first, we ran Python modernize and afterwards pylint without checking in. And after that, for each warning pylint raised, we calculated 30 minutes to fix it, because these are the hard things. In most cases, we needed less time than the calculated 30 minutes. For each doc test we calculated 20 minutes, as some tests had to be rewritten as unit tests to support both Python versions, because it's sometimes quite difficult that a doc test runs on both versions. These tests, which had to be converted, sometimes took more than 20 minutes. We calculated 5 minutes for each Python module, including the test modules, to convert them. 2 minutes for each Python module Python modernize had touched to maybe fix the mess the tool created. Plus 135 minutes base effort per installable Python package, aka a package with a setup.py, which can be installed via pip. These numbers added up to a budget which was more than enough to migrate the code. We created a plan for the whole migration. We planned 19 working phases, one iteration each month, with up to 2 weeks of implementation and testing. So there was still time for bug fixes and new features outside the migration project. So the customer would not have liked it that we stopped the whole development and bug fixing during the migration. Be aware, this 19 working phases were not only the migration from Python 2 to Python 3, but also from ZOP 2.13 to ZOP 4 as the main dependency. And this maybe was a harder part. Additionally, we fixed some technical debt, and as we were working on the code, actually we deployed a version running on Python 3 after the 15th iteration. So we were a bit faster than expected. We originally planned to roll out after each of those 19 iterations, but the customer was not able to test the whole CMS that often, because the trust in the automatic tests was not too high. And so we decided to have a rollout every 3 months. Each rollout was shipping the current status of the Python 3 migration as it still was Python 2 compatible. Even the first big rollout on Python 3 could have been switched back to Python 2 if it would have failed utterly on Python 3. So the bug fixes would have been deployed, but then on Python 2. Now I'm going to give you some tips and lessons learned. The migration project might take a while. Aim to use a recent Python 3 version, so you do not have to start the next small migration project the day after the rollout. Python 3 seems to be a fairly good starting point. Newer Python versions might make it a bit harder to still support Python 2. Merge often to the main branch. If you follow my suggestions, your code will run on Python 2 and Python 3, so there's no need to keep it on a separate branch. Go the route of the small steps. Your project might seem small enough to directly migrate to Python 3 without this intermediate step of supporting both Python versions. We did this in another seemingly small project and got burned. The changes of updating the dependencies to the newest versions and updating to Python 3 together were too much to get it running. So we had to add back Python 2 compatibility. Caution, there are no tools. And to analyze the problems of the new dependencies in Python 2 and then port to Python 3 again. So it took time and money. The Python 3 migration of union.cms took about 1.5 years for the 19 working phases. We could have done the migration in a much shorter period of time, but we wanted to be sure that it was always in the deployable state and features and bug fixes were always possible, so that we even have time to work on features and bug fixes. And the achievements in the migration projects should not be broken again by these new features and bug fixes. If you are still running Python 2.7 in production, it should not matter to keep doing so for some extra month to gain the extra certainty that the migration will not break everything into pieces. That's all. Thank you for listening.